Would you like to explain what this is?
Okay, essentially what this is was the end result of the Turbidity project. As I explained in the previous video, part of the process was that they realised that everything had to be black, it had to reflect no light, because we had issues with the little tubes that we were using, and you could notice by holding them even you'd get a change in the reading. So they realised they had to totally block the light out. The other part of that was in building this, they were going to put that inside, and then they realised, hang on, it's got little lights, little LEDs on it. So
that would affect the results, yep.
Throw the reading out as well. So really it was just the whole, this part of it was interesting for the girls because they had to really think about how they were designing it, what they were using and why, and how they were going to do that. I learnt a lot in the process of doing that. I learnt a lot about things like turbidity. I didn't know what it was to start with, and I also learnt a lot about how you interpret signals, the sorts of things that will interfere with your readings. I guess the technical specifications of certain sensors and how they function, and I think the trick in all of that is being able to take something that's fairly complex and then break that down in a very simple way so that students can understand it. And that's the real challenge, being able to translate that into something they understand. At the same time, you're building into that an understanding of things like how you measure frequency, voltage. You're looking at things like your ADCs, digital voltage converters, and what that means. When you look at measuring on these, you're looking at something that's putting out 1023 different data points of a 5-volt signal, and so you've got to work out, well, what does that mean in terms of temperature? How do you turn 1023 into something that represents Celsius or Fahrenheit, or in this case, the frequency of light.
So that's the data visualization as well. Here's the data.
Yes.
How do you convert that into useful information as part of that?
That's right.
And how did you find the students went with actually doing the task? What lessons did you? There's a lot that you learned just in how do I do it as a teacher, but what about the students?
I think we started off from that big picture. We started off from the point about the water essentially and why it was dirty. Why that water's dirty? What's that mean? And then went from there to the whole thing about, well, why is it important to talk about turbidity once we'd found it, discovered the word. What did it mean? And we found, there were 500,000 kids around the world that died from drinking turbid water each year. So then it became an important thing for the girls in terms of the project. So I guess too, the thing about starting with that big idea and talking about that, really exploring that, well, what does it mean? What are the realities for people? Is it gives them a reason to really explore what they can do with it. And I think it's also part of the reason why they stick with it, because if you start from, okay, let's just use these sensors and measure signals, you pretty rapidly lose kids. They're not really interested in what they're doing or why.
But that problem of, can we design something which will show that this water's clean enough to drink?
That's right.
Was what you found was that authentic task that inspired them?
Well, that's what it's about, isn't it? It's that authenticity. If it's not relevant, it's not authentic, then they're not going to be interested and they're not going to explore it.